Hey, how's it going, everyone? Welcome back to day 3 of the 30-day LeetCode challenge. My name is Taha, and yesterday I covered a question called design hash set. If you didn't get a chance, make sure you check that one out. Today, we're covering a question called valid palindrome. Given a string, determine if it's a palindrome, considering only alphanumeric characters and ignoring cases. By the way, I hope you guys are trying to do these questions every single day and follow along with what I'm doing, because if you keep doing these every day, then soon enough, you'll be coding at speeds faster than a race car. Palindrome joke. So note, for the purpose of this problem, we define empty strings as a valid palindrome. Okay, great. So this palindrome question is a very common question that comes up in interviews, and I think it's something that everybody should try to cover at least once. So as usual, before we get right into the code, let's break this problem down a little bit. First of all, what even is a palindrome? Essentially, a palindrome is just a word that can be read the same from forward to backwards, such as kayak, level, race car. Now, when I'm thinking about a solution to a problem, one of the things that I like to do is just think about how my brain already intuitively finds the answer to a problem. So like when I look at kayak, I can already see, well, it looks like a palindrome because the word is mirrored on both sides. So same thing with level and race car. So I take this thinking and I try to break it down into small, discrete steps that I can write in my program. So what's actually going on here in my brain? Well, basically, I look at the beginning of the word and the end of the word, and I look at if they're the same character or not. So first of all, I look at K, which is the left side. And then I look at the right side, which is also K. And then my brain goes, okay, they're the same. Let's look at the next characters. Okay, then I look at A, and I see that the A's are the same. And then we come to the middle, which is Y. And once I get to the center, I know that both words are the same on both the left and right side, therefore it must be a palindrome. So we can actually take this logic and apply it directly to our program. Now, LeetCode actually made this question a little bit more interesting because now, instead of just regular words, they actually threw in characters that are non-alphanumeric, such as at, blah, blah, blah. You can have symbols that are not part of the alphabet and they're part of your string. And your program should still be able to figure out if it's a palindrome or not. So let's think about this random example I threw in here. Is this still a palindrome? Technically, if you only look at the characters that are alphanumeric, meaning the characters that are only part of the alphabet and that are digits from 0 to 9, this is still a palindrome. All we have to do is ignore the characters that are non-alphanumeric. So what our program will do is we'll start at the left and we'll start at the right like usual. But now, when we're moving our pointers along the string, we're actually just going to skip these characters that are non-alphanumeric. So for example, we start at K and K. Then we move the left pointer to the right. And we notice that this is non-alphanumeric. So we're going to shift it to the right again. Same thing, shift it right, non-alphanumeric, shift it right. And we'll keep shifting right until we reach a character that is alphanumeric. And we'll stop here. And we'll do the same exact thing on the right side. Right now we're at K, we'll go to A, and okay, great, this is alphanumeric, so let's stop here. Now we'll compare where the right pointer is and where the left pointer is. And clearly, they both point to the same character. So let's repeat the process. Our left pointer will go up one, and our right pointer will go up one again. This is non-alphanumeric because it's a white space. Then we'll decrease the right pointer again, and again, and again, until we reach a character that is alphanumeric. So we reached Y. And in this case, our left pointer is equal to our right pointer, so our program knows that we can stop here, and that this is a valid palindrome. Before I get into the implementation, I just wanted to mention that there are actually multiple different ways of approaching this problem, and I just want to briefly cover one of the other methods. I'll also show you the coded implementation of that in Python and talk about the difference in time and space complexity between the first solution and the second solution. So make sure you stick around to the end so you have an understanding of that. Here's the idea for the second approach. What we'll basically do is build another list based on our input string and only keep letters that are alphanumeric. So here's what it'll look like. Well, we're going to be looping through each character of our string, starting from the beginning. We'll look at K. If the letter we're looking at is alphanumeric, we'll keep it in our string. So we'll keep K. Next, we'll look at character at index 1. This is non-alphanumeric, so we're not going to keep it in our string. And we'll do the same for every character until we get to A. and A is alphanumeric, so we'll keep it in our string. Then we'll get to Y. It's alphanumeric, so we'll keep it. Then we'll pass all these characters that are non-alphanumeric. We won't keep them, but we'll keep the A and we'll keep the K. Now what we can simply do is reverse this string and see if the reverse string matches the new string that we just created. Alright, so let's start with implementing the first solution. I have the basic code that we have from the question, as well as some tests that we can run after we've implemented this. So I think right off the bat, we want to start off by saying, if the string is empty, then we'll just return true, because the question said empty strings are considered palindromes. Alright, and the next thing that we want to do is, remember, we have a left and a right pointer. So we'll initialize our left to 0, and we'll initialize our right to the length of the string -1. So it's starting at the rightmost index. Now what we're going to be doing is incrementing our left and decrementing our right pointers. But we only want to be doing this while the left is less than the right. Because once the left has crossed the right, we know that we've analyzed both halves of the string. So let's start off by telling our code to keep increasing our left pointer if we're not looking at an alphanumeric character. So while not the string at the left index is alphanumeric, and Python has this built-in function that tells you if your character is alphanumeric. So while the left pointer is not alphanumeric, and we still have the left less than the right, let's increment our left pointer. Okay, let's also do this. Let's also just copy over the same logic for the right. So while not s at r is alphanumeric, and the right is greater than our left, let's decrement the left pointer. So once both of these loops have run, the left and the right pointer will both be at characters that are alphanumeric. Now here is where we will do the check. So if the string at the left pointer, and we have to remember we have to keep this in lowercase because the question said to ignore caps. So if the string at the left pointer is not equal to the string at the right pointer in lowercase, then we will return false because the string is not mirrored on both sides, therefore it's not a palindrome. However, if they are equal, we'll just increase the left pointer by 1 and we will decrement the right pointer by 1. And then our loop will go back and check, is our left still less than the right? Then it will run all this logic again. Once we're out of this loop and the left is either equal to the right, as in both characters are overlapping at one character, or if this was an even string, for example, then the left would have crossed the right. Therefore, we've already examined the entire string. We can return true. So that's the solution for the first implementation. Let's just quickly run these tests and see what happens. All right, so race car is a palindrome and it ignored these non-alphanumeric characters, as well as this Nelly's simple thing that the question gave us in the example. So let's talk about the second way that we can implement the solution to this problem. So the idea here is build a new string that doesn't involve any of the characters that are non-alphanumeric, and then reverse that string and see if that string equals the original string. So let's create a variable called parsed s, and we want to start off with an empty string and we want to join new characters to it. Python has this join method where, as you can see, it takes an iterable, and every time it iterates over an item, it'll join it to the string that's on the left side here. So essentially we want to loop through each character, see if it's an alphanumeric, and turn it to lowercase and add it to our string. So we'll go char for char in s if char dot is alnum, and then we'll turn all of this into lowercase. So it's saying loop through every character in s and keep that character if it is an alphanumeric character. And then after we've done all that, we'll turn it all into lowercase. So the way that we're going to reverse the string is using slicing. If you're not too familiar with slicing, let me briefly go over it. Let's say you have some string s equal to Taha's code camp, right? What slicing lets you do is specify a starting index, an ending index, and a step, and it'll generate a new string for you. So for example, let's say I want my string s from the 0th index, and when you specify the end, it'll go up to, but not including the number that you specify. So let's specify up to index 3, but not including 3. And this will print the first 3 characters of our string. Let's say that we want to print every other character from our string from start to end. We'll say s, starting from 0, going up to the length of the string, and we'll be stepping by 2 each time. This effectively prints every other character in the string. We're going to use the same logic for reversing the string. So what we'll do is we won't specify a starting index, we won't specify an ending index, but we'll specify a -1 as the step. The negative just means start at the right side of the string, okay? And the 1 just means step by 1 every single time. So this will start at the right index and work its way backwards up to the beginning of the string, therefore reversing the entire string. So let's use that simple logic here. We want to say reversed s equals parsed s, no start, no end, starting from the end of the string, stepping by 1 each time. So we're just going to say if reversed s is the same as parsed s, return true. Actually, a cleaner way of writing this would just be to say return this equal to this. So our function will just return whether this statement is true or false. So guys, I've submitted both solutions. Let's go over the runtime and space complexity for the first solution. The runtime is pretty good, 97%, but the usage of memory is around 30%. This could definitely be improved. I'm actually not 100% certain on how to make the usage of space here more efficient. I've only used 2 variables, left and right, and I'm not too sure on how to save on space anymore. So if you guys have any suggestions on that, let me know. Let's take a look at the second solution. So the runtime is awful, and that probably has to do with the fact that we're using the join by looping through every single item in the string, whereas in the first solution, we're only looping through while the left is less than the right. The space complexity here is a little bit better. I could probably make both of these solutions a lot more efficient, but it's currently 1:25 in the morning. I have work tomorrow. So if you guys have any suggestions on how I can potentially make any of these solutions more efficient, let me know in the comments below. If you liked this video and you learned anything new, or you just enjoyed the process of solving the problem, feel free to like and subscribe, and I'll see you in the next one. Thanks, guys.